Hey guys, we are going to look at 11.2 transformation of data, which means changes that take place. So we're starting off with these 5 test scores, and we're going to find the measures of center, mean, median, and mode. Mode is one you can find pretty quickly, the thing that is most often occurring, and that is 84. If I write these in order, I'm going to have 77, 82, 84 twice, and then 85. So if I do what I got to do to get a median, I land in the middle at 84. And here I'm going to add them all up. When I do that, I get 412. There are 5 scores. So I'm going to divide by 5. And my mean is 82.4. So we learned how to do all that yesterday, which was a review from a long time ago. Range is going to be my highest value minus lowest value. So my range is 8, and that is a measure of how spread out the data is. Okay, so let's say the teacher decides to add 5 points to all the test scores, which never happens in real life, but we're pretending. So find the new scores. All right, let's take our old scores. I'm just taking like 77 and adding 2. Then I'm going to take 82 and add 2. So I'm just literally adding 5 to each score that was in my list before. Then my new mode, instead of being 84, you can see the repeat here is 89. My new median, if I chop each end, is going to be 89. And my new mean, when I add those up, I'm still dividing by 5, and I end up with a new mean of 87.4. So if you look at your mean, median, and mode compared to the old ones, 87.4 versus 82, 89 versus 84, 89 versus 84. Each of these measures of center went up by 5, which is the number I added to the data. When I go to do my range, my new max minus my new min is still 8. So that's the same as before. So we're going to look at this kind of in general. What happens is if you have a set of data like this and you just add or subtract, you literally are just moving the numbers up or down. You're shifting the whole thing. So this is supposed to say slide. A constant, meaning the same number like I did 5, is added or subtracted to each value. What happens is everything moves up. All the scores go up 5, down 5, whatever you choose to do. So because it's a slide, it doesn't spread out, like it doesn't become a bigger range. It's just moving the whole set up or down. So what stays the same is things like range, and then IQR, if we had done that interquartile range. Standard deviation would stay the same. Anything that's a measure of how spread out it is, because it doesn't become more spread out. It just moves up or down. Then what does change, you saw, was the mean, median, and mode. Because if I have my mean, median, and mode kind of measuring the center here, and you move the whole data set up to here, well, my mean, median, and mode are going with them. But the range from one end to the other is going to stay the same. It's not more spread out. It's just moving around. So here, the things that changed were mean, median, mode, anything that was a measure of center. So measures of center change. So measures of center move, mean, median, and mode. And they change by the number that's been added or subtracted. So whatever number you add or subtract, in my case, mine all went up 5. Just in this example. So in general, if you add n to every value, you take all the scores and you add 2, take away 1, add 5, whatever you do, your mean, your median, and your mode, all the measures of center, you will add or subtract that value to those. Your range and everything else, those things will stay the same. So you want to kind of keep track of that. Mean, median, and mode will move. You'll add or subtract whatever the number was that you changed each value by. But your range, IQR, standard deviation, anything that measures how spread out the data is, which I spelled wrong here, that's all going to stay the same. It will not change. Okay, what if instead they decide to cut the values in half? So you're going to multiply by a half, or you could think of it as divide by 2, so that it didn't get weighted as heavily in the grades. They wanted to not be as impactful in the grade book, which does happen. So let's find our new scores. So we're going back to our original scores. Our original low was 77. If I divide it in half, it's 38.5. Our next score was an 82, so half of that. Our next was an 84, half of that. 84 again, so half of that. And then our high score was 85, so half of that. So these are our new scores if we divided everything by 2 or multiplied by 1/2. Same math. So when I recalculate and I look at my mode, now it's 42. It used to be 84. This is the old one. When I find the median by like chopping my numbers one at a time until I get to the middle, now it's 42. It used to be 84. When I add them all up, I get 206. When I divide that by 5, I get 41.2. It used to be 82.4. So you can see that all of these, mean, median, and mode, are now half of what they used to be. So again, what happened to the data happens to them. But what's going to be different now is if I find the range, I'm taking my highest value and subtracting my lowest value. And when I do that, my range is now 4 and the old one was 8. So that's actually half as well. With adding and subtracting, it didn't change the range, but with multiplying and dividing, it does, because you're shrinking it all down. So a constant is multiplied or divided, not added or subtracted, multiplied or divided. What stays the same? And the answer is nothing. If you multiply everything or take half of everything or multiply everything, and by the way, that's going to be percent too, because like what I just did was find 50%, because 50% of the old scores would turn into 0.5 as a multiplier. So what changes here is everything. Everything gets changed. So my old data might have gone like that, but if I make it half as big, everything gets half as big. So I'd end up with something that's only going to be that wide in terms of a range. My mean, median, mode, everything's half of what it used to be. So how do those values change? In this case, it's going to be half, but it's going to be changing by the number that you multiplied or divided. So in this case, it's half. So in general, if you multiply or divide everything, all the values, and you have to pay attention to whether you're adding, subtracting, multiplying, or dividing, everything is going to get multiplied by n or divided by n. Whatever you did to the data, you do to everything. Versus when we were adding and subtracting, the only thing that changed were the mean, median, mode. So adding and subtracting change the measures of center. Multiplying or dividing changes everything. So when you have a situation like this, you have to decide if you're adding, subtracting, multiplying, or dividing. So in this case, it says the numbers describe the waiting times at urgent care. What happens if someone with a super emergency comes in and everyone's wait times are increased by 15? If you now have to wait 15 more minutes, you are adding 15 minutes to everybody's time. So think about it. Adding changes measures of center, but not the range or standard deviation. So for these three, I would add 15. My new mean will be 15 higher. Now you'll wait 37 minutes. My new median is 15 higher than that, so 20 plus 15. Here, my new mode is going to be 24 plus 15, so 39. But from highest to lowest wait time still remains 18. And my standard deviation is 5.67. So like in this case, it means like standard deviation means you're like, okay, you usually have to wait around 35 minutes, give or take 5.67 minutes. So it's like how close to that average things are coming in. So these two stayed the same. In our last example, it says here are the prices of the candy bars in the store, and then it gives the mean, median, mode, range, standard deviation. What happens if all the candy bars are 30% off? Okay, 30% is not adding or subtracting. When something is 30% off, you actually pay 70% of the original price, which equates to multiplying by 0.70. Because if you pay 70% of in math means multiply, so you're going to be multiplying by 0.7. Since it's multiplication, we learned everything will change. And so this is going to get multiplied by 0.7. So is this. So is everything, not just the measures of center. Everything is going to shrink to 70% of what it was before. So when I multiply 1.22 times 0.70, keeping in mind that it's money, so I'm only going to use 2 decimal places. Now it's only 85 cents. If the mean was 1 and I'm meaning $1, now I multiply it by 0.7 and I get 70 cents. If the mode was $1.50, once I multiply it by 0.7, it goes down to 1.05. My range was 150, so that'll go down to the same thing because I'm multiplying it by 0.7. And my standard deviation, meaning like they kind of deviated from the norm by about 42 cents. And so when I take that times 0.70, I get 0.294, so like about 29 cents is now the new standard deviation. So in this case, nothing stayed the same because I was doing multiplication. Okay, so the last thing we need to know how to do is to find a missing value. So think about what we know. We know that average or mean is going to be the total divided by the number of items. So in this problem, it says the average age of 6 dogs, so that is going to be the number of items, is 40. So it's telling you that the average is 40. Then it goes through. Fluffy weighs 62. Rex weighs 24. Bosco weighs 46. Dixie weighs 57. Peaches weighs 35. But we don't know how much Daisy weighs. So, of course, I didn't leave enough room, so I'm going to cram Daisy in over here for Daisy. All right. Don't make this problem harder than it is. You know this is 40. You know this is 6. You can add all of these up on your calculator and find the total of the first 5 dogs that you do know. When I did that earlier, I had 224 plus whatever Daisy weighs. I'm going to throw this over 1, if that makes it easier. You're multiplying, cross-multiplying, or you can, if you think of it instead, say, oh, I'm just going to multiply both sides by 6. Either way, I end up with 240 equals 224 plus Daisy's weight. I need the total to be 240, but it's only 224. So when I take that away to figure out what Daisy might have to weigh, she only weighs 16 pounds in order to make that have an average of 40 pounds. So if you think of this as average, the kind of the formula where the mean is going to be the total divided by the number of items, then if you almost know the total except for this one thing at the end, you can work backwards to figure it out. So there you have it, my friends. Good luck.